All right, so looking at the exercises for this section 2.11, it says, for the exercises that follow throughout the book, if a question states a proposition, then prove this proposition. For example, see question 10. So if we look at question 10 on page 74, it says, if a line is drawn through the vertex of an isosceles triangle parallel to the base, it bisects an exterior angle at the vertex. Okay, so you should be able to read that at this point and know exactly what they're talking about. We know that an isosceles triangle is one where all three sides are equal and it's equal angular, okay? Then it says, draw a line through the vertex. This is the vertex. If this is considered our base, then this is our vertex. And it says, draw a line through that so that it's parallel with this base. Well, that's not too intimidating. We'll just come along here and draw our line parallel. And again, with our compass, this would be precise, but here we are drawing this, okay? And what it says is that we're going to prove that it bisects the exterior angle at the vertex. We also know that an exterior angle is an angle that when one of the sides of the triangle is extended, that is considered an exterior angle. So let's do this. Let's call this A, triangle ABC, and then I guess let's do this D and E so that we have some reference points for our angles we're going to talk about. So what it's asking us to do is it's asking us to prove that it bisects the exterior angle at the vertex. So what we're proving is we're proving that angle DCE is equal to BCE. Okay, so that's what we're trying to prove.
Can I have some of those tips? Because I ate all those flour sandwiches.
Let me finish my stuff and then I'll get it for you, okay? So go over there and wait for me. No, you're not getting those chips. You need to wait. Okay, so if we were going to do this as a proof, okay, our statements and our reasons, okay? So if we were going to color code this, we need to prove that this angle is equal to this angle. There we go, the two blue angles, okay? So now, statement one, we're going to write what we're given. Well, we're given triangle ABC is isosceles. I don't think I'm spelling this right. There we go, I'm going to abbreviate, and that is given. We're also given that line CE is parallel with AB. Okay, so those are our items given. Now, let's look and see what we could do. Okay, what have we already learned? Let's look at some of these corollaries that we learned. Now, remember, we're trying to prove that it's a bisector. So can we use some stuff we've just learned about parallel lines? How about Theorem 8 says that if two parallel lines are cut by a transversal, then the alternate interior angles. Well, if we look at this, if we say CE, we know that CE and AB are parallel lines, then we know that if we're talking about alternate interior angles, then that means that angle B and angle C, let me draw that with green here. We know that then these two angles should be equal because of Theorem 8. Let's look at some of these other ones. How about Corollary 8.1? If two parallel lines are cut by a transversal, then corresponding angles are equal. Well, our corresponding angles are the ones that were on the outside. So that means that, let me do color code again, do orange. By Corollary 8.1, A and angle CDE should be equal. All right, let's look and see if any of these other ones will help us. How about Corollary 8.2? If two parallel lines are cut by a transversal, then the sum of their interior angles on the same side of the transversal is equal to a straight angle. I don't know, that may or may not help us. Okay, and then some of these others. How about, what do we know about an isosceles triangle? We just said that all three sides are equal and all three angles. So if we know that A is equal to B, what do we know about angles, angle BCE? Do we know anything about it? We haven't color-coded it anyway to see if it's equal. Well, look, it goes back to right here, Theorem 8. If two parallel lines are cut by transversal, then the alternate interior angles are equal. Well, look, let me color code this again. We'll choose purple. Angle B, ABC, and angle BCE are alternate interior, so they're equal. So I think that we can just use Theorem 8 and these corollaries to show what's equal to what, and then by substitution we'll end up with these two equals. So let's go back and write down what our color coding means. Okay, so let's just take angle A equals, this is doing the orange one, angle DCE, and the reason is because they are corresponding angles, so it's corollary 8-1. Okay, so that's all we're going to do on that. Now let's talk about the green right here that I've done. Angle B equals angle no, it doesn't equal that one. I don't know why I did that. Why did I say it equals that? I can't remember now. I can't say that because I don't know nothing about them, but I do know that angle B, so scratch the green there. Well, I can't scratch it. Oh well. So I do know that angle B, I have to go back and look at my film and see what I was talking about, so ignore that part. I'm already going to cut it out. Angle B, purple-wise, is equal to angle BCE, and that's also corollary 8-1. Okay, now I know that, what do I know about angle A and angle B? What do I know about angle A and angle B? I know that they're equal by definition of an isosceles triangle. So I know that angle A equals angle B because of definition of an isosceles triangle. Well, and also actually angles opposite equal sides are equal, okay? Which is the definition of an isosceles triangle as well. Okay? So now, number 5, I can say that angle, because see, look, angle A and angle B are equal to the two angles I need to deal with, and by substitution I can say that angle DCE, which is this one, DCE, equals angle BCE, which is this one right here, my two blue ones that I'm trying to prove, by substitution. But again, don't forget the question was, I need to prove that they are bisector, and so now I can say that line CE bisects angle, the exterior angle, which is BCD, by definition of an angle bisector, because if a line drawn through an angle creates two equal angles, then that is the definition of an angle bisector. Okay, this is all about using what you have already learned. Okay, so that's number 10.